Okay, let's unpack this. Picture a big excavator out on a job site. It's doing heavy work day in, day out, but maybe its movements are getting a bit sloppy, loose.
Yeah, that swing doesn't feel quite right anymore.
Exactly. And often the root cause. It's worn pinholes in the joints, the places where everything pivots. So your first thought is probably, ugh, this is going to be expensive, right? Big repair bill, lots of downtime.
That's the usual reaction,
That's
absolutely. Because the traditional way, I mean, it's a massive hassle. You've got to haul this huge machine often miles away to a workshop,
right.
then take it apart, fix it, put it back together, haul it back. We're talking serious time off the job. Costly.
But what if there's a smarter approach? A faster way? That's what we're diving into today. We're looking at a really clever solution, fixing those worn pinholes right there on site.
Using portable bore welding and this pretty specialized piece of kit called a narrow spaceline boring machine.
So in this deep dive, we want to understand how these tools work, how they can bring that workshop precision right to the field, saving time, saving money.
Yeah, our goal is really to unpack the what, the how, and the why behind this whole on-site repair process, how it keeps vital gear running.
Okay, so let's start with the problem itself. Worn pinholes. What's actually happening there? Why is it such a big deal?
Well, think about the forces involved. These joints, these pivot points on excavators, loaders, things like that. They're under constant, immense stress. Friction, heavy loads back and forth all day.
Right, nonstop punishment.
Exactly. So over time, the holes where the pins and bushings sit, they just wear out. They can become oval-shaped, elongated, bigger than they should be. And that's what causes that slop, that imprecise movement you mentioned.
And that reduces accuracy, efficiency.
Definitely. But maybe more importantly, that looseness puts extra stress on everything else around the joint. It can lead to much bigger, much more expensive failures down the line if you ignore it. Sort of a snowball effect.
Okay, so a small problem gets bigger fast. And the old fix means pulling the machine off the job for ages. That's where this on-site approach comes in. Can you break down that two-step process for us?
Sure, it's actually quite logical. The first step is using portable bore welding. You bring specialized welding gear right to the machine,
Okay.
and you carefully weld material back into that worn-out hole. Layer by layer, you're essentially filling in the worn areas, building it back up.
So you're adding metal back where it got worn away, but I guess that welded surface isn't perfectly round or smooth, is it?
No, not at all. It's just rough fill, basically.
Yeah.
And that's where the second really crucial step comes in, the portable narrow spaceline boring machine.
Ah, the star of the show.
Kind of, yeah.
Ah,
So you mount this machine directly onto the equipment, carefully align it with the hole you just welded up,
okay.
and then it precisely machines away that excess weld material. It cuts the bore back to the exact original diameter, the right shape, the right surface finish.
And the really amazing part is, this all happens without hauling the main structure away, without massive disassembly.
That's the key benefit. Minimal disassembly, usually. You do the repair right there. It just slashes the downtime.
That sounds like a total game changer for keeping projects on schedule.
It really is.
Yeah.
Less downtime means lower costs, faster return to work. It's hugely important for productivity.
Okay, let's zoom in on this narrow spaceline boring machine. The name suggests it gets into tricky spots. What's special about its design?
Well, the big challenge is always getting workshop-level accuracy deep inside a complex machine, right? Your standard big boring mills in a shop, they're just too bulky. You can't get them in there.
Right, they're designed for components brought to them.
Exactly. So this narrow space machine is engineered specifically for that problem. It's compact, it's relatively lightweight, so you can actually maneuver it into those tight, confined areas.
Portable precision.
That's the idea. But it still needs to be powerful and rigid enough to make accurate cuts. Its whole purpose is bringing that precision to places you couldn't reach before without taking the whole thing apart.
So it avoids that massive teardown. What are some of its key capabilities? What makes it work so well?
Well, first off, the boring range is pretty impressive. Typically, they can handle holes from maybe 30 millimeters up to 300 millimeters. That's what, about 1.2 to nearly 12 inches.
Okay, that covers a lot of ground.
It does. It covers most of the common pin and bushing sizes you find on heavy equipment, so it's very versatile.
And it's not just for those main pivot pins.
No, not at all. You can use them for things like flange connection holes, main engine base holes, bearing seats, even marine applications like rudder machine seats on ships. Precision alignment is key there too.
Interesting.
And many models can also do end-face machining.
What's that for?
That's for making sure the flat surface at the end of the bore is perfectly flat and square, crucial for seals, or for making sure a bearing sits just right,
Ah, okay. Adds another layer of usefulness. Now, you mentioned tight spaces. These machines must sometimes operate in really awkward positions, right? Upside down, sideways.
Absolutely. And that's a critical design point. Many use a sealed lubrication system. Sounds minor, but it's actually key.
How so?
It means they can run in any orientation, horizontal, vertical, even completely upside down without leaking oil or losing lubrication. Think about fixing something on the underside of a boom. You need that flexibility.
Yeah, definitely.
And then there's stability. For accurate cutting, you need smooth, vibration-free operation. So they use heavy-duty bearings, often with zero backlash in the spindle. That translates directly to better surface finish and tighter tolerances.
It sounds like they've really engineered these for the realities of field work. What about power and ease of use? You said lightweight but powerful.
Exactly. It's a balance. They need to be portable enough for one or two people to set up in potentially cramped spots,
Mm,
but they still pack high horsepower motors for efficient cutting.
right.
Many also have uh, stepless speed control with constant torque. That lets the operator really fine-tune the cutting speed for the best results depending on the material. And because setting up quickly and accurately is vital.
Yeah, I imagine setup is half the battle.
It can be. So they often include things like self-centering cones to help speed up that initial alignment process. Makes it a bit easier under pressure.
Okay, so the machine itself is pretty sophisticated, but, getting it perfectly positioned inside the guts of a real machine, often greasy, maybe dark, definitely cramped,
Hmm.
that must be a huge challenge on its own.
You've absolutely hit on a critical point there.
Right.
Even with the best machine, the actual on-site setup is where a lot of the skill comes in. It presents some major hurdles.
Like what?
Well, first, just physical access. Sometimes just getting the boring bar and the drive unit into the right position is a struggle. Then achieving that precise coaxial alignment.
Making sure the new hole lines up perfectly with maybe another hole or a reference point.
Exactly. If you're boring two holes on either side of an excavator arm, they have to be perfectly in line. Otherwise, the joint won't work smoothly. That's crucial.
I can see that. What else?
Getting the machine mounted rigidly is another big one.
Mhm.
You're often dealing with surfaces that aren't perfectly flat or clean.
Mm,
Any vibration during cutting ruins the accuracy.
okay.
Core visibility is almost always an issue deep inside machinery. And very often, standard clamps or mounts just won't work because of the shape of the part, so you need custom fixtures.
Custom solutions on the fly.
Sometimes, yeah. And what if the original hole is so badly damaged you can't even use it as a reliable starting point? Then you have to establish a whole new reference line, a new datum based on other parts of the machine. That adds complexity.
Wow. It sounds less like just machining and more like complex mechanical puzzle solving in a difficult environment. So how do technicians actually manage all this?
It takes experience, the right auxiliary tools, and frankly, some ingenuity. For visibility and access, they're often using mirrors, maybe small cameras called borescopes.
Yeah.
And yeah, sometimes working in really awkward positions.
What about?
For that critical alignment, they use specialized kits. Things like precision combs that fit into existing bores, adjustable spiders that center the bar, sometimes even laser alignment systems, plus lots of careful measurement.
Lasers make sense for lining things up accurately.
They help a lot. For rigid mounting, they might have to fabricate custom brackets right there, or use powerful magnetic bases if it's a steel structure, or just use multiple clamps very strategically to lock it down solid.
No movement allowed.
None. Good lighting is non-negotiable. Powerful portable work lights are essential. If hydraulic lines or wires are in the way, they have to be carefully protected or maybe temporarily moved aside. And like we said, custom fixtures are common. Sometimes they'll weld temporary brackets onto the structure just to mount the boring machine securely, then cut them off afterwards. If the original bore is unusable for reference, well, that's where establishing new datums comes in, using other features of the machine geometry. It's highly skilled work.
It really sounds like it. A mix of high-tech tools and very practical, hands-on problem solving. So after all that setup effort, the big question is, how accurate can these on-site repairs actually be? Can you really match workshop quality?
You know, it's surprisingly good. Modern portable machines in skilled hands can achieve really impressive accuracy. Let's talk surface finish first.
Okay, how smooth can they get it?
Typically, they can achieve finishes down to Rao 1.6 micrometers, which might not mean much on its own, but the point is that's very smooth. It's crucial for how well a bearing or bushing works and how long it lasts. Reduces friction, reduces future wear.
Wow, okay, 1.6 rad, that's smooth. What about the size, the diameter of the hole? How close can they get?
Very close. Tolerances are often held extremely tight. Think maybe less than 2 thousandths of an inch error, sometimes even better.
Tiny margin.
Very. And that ensures the new pin or bushing fits just right. Not loose, which causes wear, and not too tight, which could cause binding or make assembly impossible.
Hmm.
They can also fix out-of-round holes, bringing them back to almost perfect circularity. That's vital for distributing the load evenly.
Right, fixing the shape, not just the size. What about when you have multiple holes that need to line up, like on that excavator arm example?
That's coaxiality.
Yeah.
And yes, with careful setup, they can achieve very high levels of alignment between multiple bores. That's absolutely critical for smooth movement in articulated joints. Prevents binding, prevents stress, and finally, cylindricity, making sure the bore is straight and parallel all the way through. Consistent support for the pin.
It's genuinely impressive that this level of precision is possible out in the field under potentially difficult conditions. Really speaks volumes about the technology. Now, we've focused a lot on excavators, but who else benefits from this? It sounds widely applicable.
Oh, absolutely. Excavators are a great example because everyone can picture them, but the technology is vital across many sectors. Anywhere you have large, critical machinery that's hard to move or take apart.
Like what other industries?
Well, stick with construction and earth-moving things. Bulldozers, wheel loaders, cranes, big drills, articulated trucks, they all have similar wear points.
Makes sense. Same kind of stresses.
Then there's mining. Massive equipment shovels, drag lines, haul trucks. For them, on-site repair isn't just nice, it's often the only practical way. Downtime is incredibly expensive.
I can imagine. What else?
Marine and shipbuilding is a big one. Reboring stern tubes for propeller shafts, rudder bores, crane mounts on ships or docks. You're not taking a ship to a machine shop easily.
Definitely.
Power generation, working on turbine casings, generator housings, linkages and dams. Oil and gas, too, especially offshore platforms. Repairing pump housings, crane pedestals, drilling equipment like BOP stacks.
Critical infrastructure.
Exactly. Even railways use it for engine blocks, gearbox housings, pivot points on bogies, and heavy manufacturing. Steel mills, think bearing housings on rolling mills, huge gearboxes, flanges on large pipes.
It really is a broad list. The common factor seems to be large, essential equipment where traditional repair is just too disruptive or costly.
That's the core of it. Bringing the precision repair to the machine saves enormous amounts of time and money across all these fields. It keeps essential assets working.
So, wrapping this up, it seems clear that this combination of on-site bore welding and narrow spaceline boring is a really smart, efficient solution for a common, costly problem in heavy machinery.
Yeah, it sidesteps all the headaches of transport and major disassembly. You bring the fix directly to the problem.
And understanding how it works, the tech involved, the skill needed, it really highlights how innovation tackles these big industrial challenges. It keeps so many crucial industries moving.
Absolutely. It's about applying precision engineering in demanding real-world environments.
You know, it really makes you think about the ingenuity involved here, taking workshop precision and making it work reliably out in the dirt or on a ship or up on a platform. It begs the question, what other huge maintenance headaches out there are just waiting for a similar kind of clever on-site solution? As this portable tech gets even better, what totally new things might we be able to repair or even build in place that seem impossible today? Definitely something to ponder.